All right, so last section we're going to look at in chapter 1 is 1.6. So this is on basically how we can take functions and combine them together. It's almost like combining like terms. And we're going to look at 4 basic operations we can use. And then we'll look at a 5th one called composition.
During Thursdays, do you teach another lesson or do you do like a review?
Most Thursdays, yeah, will be just a regular lesson.
Okay.
What I will do at the end of class on Thursday usually is put a list of topics that are on the test.
Okay.
If I can't get to it in class, I always make sure I put it in the video so you can see all the topics on the test. So I will do that for tomorrow.
Okay.
So the idea we're going to look at first is taking 2 functions that are given to you, like maybe one will be f of x, one will be g of x, and combining them together to make a new one. So let's start with these 2. So f of x is the function x squared, and g of x is the function square root of x plus 1. There's not really much we can do here because they're not like terms. So one new function I could find would be f of x plus g of x. That's one way I could take these 2 functions and combine them together to make a new one. That would be f of x plus g of x. Now, if f of x was x squared and g of x was like 3x squared, well, in that case, those would be like terms. And then when I add them, I could say 4x squared. But in this case, a quadratic and a square root function are not like terms, so I can't do anything with that. That's the final answer. How about if I wanted to take these 2 functions and divide them to create a new one? How do you think I would write f of x divided by g of x? What would I write down? Nope. Yeah. Yep.
Would it be like x squared over the square root of x plus 1?
Yeah. It would be x squared.
It's literally that.
Yeah. Yep. And now we just have to be careful because this is another rule. We can't leave a square root in the bottom.
Mm-hmm.
So what we could do to fix that.
It's called rationalizing, right?
Yep. Rationalizing by multiplying the top and the bottom by the square root. This has nothing to do with what we're really learning today. Rationalizing is just something you have to do if you ever end up with a square root in the bottom. So that's good you remembered what that's called. And then when you do this, there's not really a lot you can do with it. When you multiply the top, you get x squared times the square root of x plus 1. And then in the bottom, the square root of x plus 1 times the square root of x plus 1 cancels the square root out. And you're left with x plus 1. So this represents combining the f of x and the g of x function using the division operation. This represents combining f of x and g of x using the addition operation. And I could have done subtraction and I could do multiplication as well. But any questions on how we took those 2 functions and combined them together to create a new one? Okay. Now, when we combine them, f of x has its own domain and range when we start the problem. G of x has its own domain and range. When you combine to create a new function, you are potentially creating a new domain and range. So that's what we really want to be able to figure out. When we take and create these new functions, what is the new domain and what is the new range? Well, it has to do a lot with the original domain and ranges. So the idea when you combine them is that the domain of the new functions are all x values that work in both original domains. Okay, one way to think of it is kind of like a Venn diagram. Okay? If these are all the numbers, I'll use our labels, that work in f of x. And these are all the numbers that work in g of x. The domain, when we combine f of x and g of x together, are all the numbers that work in both. So the domain is all numbers that work in both original functions. Now, there is one other thing you do have to be careful with, and that's division. Because what are we never allowed to do with division? You can't divide by 0. So if you ever create a function that ends up with a denominator and there's a variable in it, you also have to make sure that you never divide by 0. Because you might say, well, if I plug -1 into the original function, that's fine. -1 squared is 1. If I plug -1 into the g of x function, that's fine. -1 plus 1 is 0, and the square root of 0 is 0. But if I plug -1 into this new function down here, I would end up with dividing by 0. So not only do you have to make sure that the number works in both of the originals, but you also have to make sure you never divide by 0. Division is the only operation that kind of introduces that extra thing that could happen. Because with adding, subtracting, and multiplying, you never introduce a new denominator that wasn't already in your problem to start. But with division, you can. All right, so let's try a couple examples where we figure out the domain and the range. All right, so here's two square root functions. And the first thing I want to do is just figure out what the domain of these two things is, what the domain of these two things are by themselves. What numbers are you allowed to plug in for x in f of x?
Any number greater than greater than and including -2.
What about -2.5? That's okay. So it doesn't have to just be greater than or equal to -2. -3. So the way we can write, yeah, it can be equal to. So this is your domain. Let me fix that. From -3, as high as you want to go. The bracket on -3 means you can include -3. The parenthesis on infinity means you never reach it. So this is any number from -3 and up. How about the square root of x minus 2? What's the domain of that one? Ben?
Greater than or equal to 2.
Anything greater than or equal to 2. So that means from 2 as your low value, including 2, as high as you want to go. So any questions on those two domains? Or how I wrote it? I think we talked a little bit about this, but we're going to start using now. All right, let's combine these with addition. What would be the formula for f of x plus g of x? Yeah, the new expression when I add those together. Yeah?
Is it just the square root of x plus 3
Yep.
plus the square root of x minus 2?
Yeah, there's not a lot you can do, right? Those aren't like terms. An example of square roots that are like terms would be like the square root of x plus the square root of x. Well, now you could say that's 2 square roots of x. Yes, you can combine those. But if the radicands are different, you can't have them. Okay, so that's all you can do. Now, I want to know the domain. What would be the domain of that? It has to be all x values that would work in both of them. Yep.
It would just be the domain of g of x, right?
Yeah, it would be everything greater than or equal to 2. Because if you think of it as a number line, f of x includes everything from -3 going to the right forever. G of x includes everything from, let's just say it's -2, -1, 0, 1, 2. G of x includes everything from 2 to the right forever. So we're basically looking for the overlap. Overlap is 2 to infinity. Any questions on that? That's the domain. All right. How about this one? F of x divided by g of x. How about Caleb? Could you tell me what that one would be?
Would be square root of x plus 3.
Yep.
Over square root of x minus 2.
That's it. So there's your formula. Now, what would be the domain? Yep.
Maybe to infinity, but not infinity.
Yes. Why?
Because you can't use 2 because it'll make the bottom of the denominator 0.
Right.
But everything else will.
So you're still looking for the overlap. What's all the values that work in the top? What's all the values that work in the bottom? So we have the overlap. But we also have to make sure we never include a value that would cause us to divide by 0. 2 would cause us to divide by 0. So we put a parenthesis on it, which means not included. So any number from 2 as high as you want to go. So small change, but very big difference, in terms of including or not including the 2. That makes a difference. Questions on that? Okay. Let's try this. I want to graph the formula absolute value of x over x and find the domain and the range. Well, what's the domain in this case? Think of what values would you be allowed to plug in for x in that formula. Yep.
It's all real numbers except 0.
Everything except 0. So you can go as low as you want to go, up to not including 0, or you can go from 0, not including it, as high as you want to go. So if you think of it on a number line, here's 0. There's a hole in the graph there, and you can pick anything below the number 0, and you can pick anything above the number 0. That's those 2 arrows right there. Now, let's try some numbers and see what happens.
Wait, what did you say the symbol between those two order pairs was?
Does anyone remember what that symbol is? Yeah?
Or, right?
It stands for or. It's called the union symbol, but logically it means or. So you can pick a number from here or from here. Now, if you plugged 5 in for x, and you did it out, what would you get for an answer? Yep? 1. What if you plugged in 10? Still 1. 13? 1. Negative 8. Negative. So what's going to end up happening if we graph this is there's only 2 values in the range. That's it. So no matter what you plug in for x, you're either going to get 1 as the answer, or you're going to get negative 1. And the graph looks like this. Okay, if we draw that just with a little bit more detail, open circle, open circle. So if you plug in any number greater than 1, you get 1. Any number less than 1, you get -1. So this is an example where we can list every single number in the range, because there's only 2 of them. So usually what we do is we use that symbol, which means we're about to write down a set.
Is that like a bracket?
Like a curly bracket, yeah. -1 to 1. Kind of like. So that's my range. And when you put it in curly brackets like that, it means just this number and this number. That's it. This is not an interval. It's not saying everything between -1 and 1. Not at all. All right, so we can combine functions with adding and subtracting, relatively straightforward to figure out the domain. Okay, find the overlap, but also make sure you never divide by 0. So now what we're going to look at is another operation which is called composition. Composition is another way to create a new function from 2 existing functions. And the idea of composition is that you plug one function into another. So you take one function and you use that to replace the variable in another one. So rather than plugging in, say, a number, like if I wanted to do g of 2, that means in the g function, put a 2 in for all the variables. Or g of 6. In the g function, put a 6 in for all the variables. Well, this means in the g function, everywhere you have a variable, put in f of x. So you're going to be replacing the variable in the g function with the formula x squared plus 3. And the way you pronounce what's written here is g of f of x. It's just like you'd pronounce this, g of 6, g of 2, g of f of x. So what that means, if we break it down a little bit, is in the g formula, you're going to replace it with, what's f of x? X squared plus 3. That is what you're changing every variable to in the g formula. Change all the variables to x squared plus 3. So what would be my answer when I do what that says?
Just do the square root of x squared plus 3.
Yes. And that's it. That's the composition of g of f of x. Domain and range gets a little trickier, so we'll talk about that. Let's do it the other way. F of g of x. So in function f, you're going to replace it with g of x. What's my g of x? Square root of x. So look at the formula for f, and everywhere you see a variable in the f formula, replace that variable with square root of x. Yes?
So it would be the square root of x squared.
Yep, the square root of x squared plus 3, which is x plus 3. Now the fact that this happened and the square root disappeared is important, but we can't forget that we had a square root. So this square root is still going to be controlling some of the domain, even though it canceled out. I'll show you how in a second. So that's how I always write it. That's how you'll see it on the test. You might in the homework see something like this. G, a little circle, and an F. It just means this. So that's the notation that I always use on the right. But you might also see that notation on the left. I just think the notation on the right makes it clearer what you're actually doing. Okay, so how do we figure out the domain when we do a composition? Okay, it's 2 steps. The first step is eliminate any values that are not in the domain of the inside function. Okay? So if you think about, we're starting with all real numbers. That's our domain to start with. First thing we do is get rid of any values that are not in the domain of the inside function. When I say inside function, this would be considered the inside function. This is the outside. Inside is inside the parentheses. Outside is outside the parentheses. All right, so we start with the inside function, and we eliminate any values we need to from that. Then we look at the composed function, and we see, are there any other values we need to eliminate from that one? What you're looking for, when you're looking for values you need to exclude from the domain, are 2 main things. 1, you're looking for square roots. Is it possible you could ever take the square root of a negative? If that could happen, you need to eliminate those values. We do not want that to happen. So check for square roots of negatives. And 2, check for dividing by 0. If there's a value that would cause you to divide by 0, you need to exclude it from the domain. We don't want that to happen.
Okay, so that's just eliminate the square roots of negative or divided by 0.
Yes. From the inside function first, then from the composed function. So let's try one. That's especially important in the one where you have a square root of a square and the square cancels out. You have to make sure you follow those 2 steps. Okay, let's just try something with a number first. Okay, so this is even easier. You're not even plugging in a formula. You're plugging a number into the inside function, getting the answer, and then plugging it into the outside function. If I wanted to do this one, start with the inside, g of 9. So in the g formula, replace the variable with 9.
Wait. Sorry, where's the next one?
I always get it.
Okay.
I would just get it.
Oh, okay. I thought you
What's the square root of 9?
3.
3. Now, I want you to plug 3 into the f function, which was the outer function. Now it's the only function. What's f of 3? That's exactly what you just did with composition. Some people find it a little easier to think about it with a number, but this is a composition. It's just not with letters. Okay, the first one we did was with letters. Okay, let's do another one with letters. All right. So write your outer. What's going to go inside those parentheses? Yep, John. Yeah, replace g of x with what they tell me, square root of x. Now, in function f, replace all the variables with that. And what would you get? Square root of x plus 1. Very important that the square root, that the 1 is not under the square root. It should be just like that. Okay, did they say find the domain? Nope, we're not finding the domain yet. We'll do that next. Okay, g of f of x. All right, what is Layla, what's f of x in this case?
X plus 1.
X plus 1. So when I do g of x plus 1, what do I get? Yep.
The square root of x plus 1.
Same as this one?
No.
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 The square root, but x and 1 are both under the square root.
Yes, and that's the difference between a vertical shift and a horizontal shift.
Do you say it differently?
Not really. I guess if you were going to be really clear, you'd say like the square root of x and then plus 1 outside versus square root of x plus 1 all under the square root. That's how I would say it if I wanted to be clear. But yeah, if you don't say it right, it's vague which one you mean. Okay, let's try this.
Is this a new set of...
Let's just do it one way. Let's do the one on the right. Let's do the f of g of x. So find f of g of x. All right, so first thing, identify what g of x is. How about Savannah, what's g of x? Yep, square root of x. And that is what we're going to fill in to formula f. So can someone tell me, when you fill that into formula f, before you simplify it, what do you get? Nate?
C is the square root of x, and then squared minus 1.
So the square root of x squared minus 1. Good. And now can you fully simplify for me?
It would just be x minus 1.
X minus 1. So if somebody looked at that and just said, oh, that's just a line with a slope of 1 and a y-intercept of -1. The domain is all real numbers because you can subtract 1 from any number. No. Let's go back and look at the steps for the domain. Step 1, eliminate any values that are not in the domain of the inside function. What's the inside function in this problem? G of x, which is the square root of x. What is the domain of the square root of x? Yep.
That's the 0 to infinity.
Including or not including?
0.
Yeah, including. So we're already limited to 0 and up based on the inside function. Now, look at the composed function. Is there any number that you cannot subtract 1 from?
No.
No. So the composed function doesn't add any additional information here that we need to take into
Alright,
account.
so the composed function is the thing that you get after you... I guess that makes sense.
Yeah, it's the x minus 1. So in this case, the x minus 1 is not significant in terms of the domain. The only thing that was important was the original inside function. And from that, we were allowed to pick values from 0 and up. So that's a little tricky, because sometimes I get an answer here of all real numbers. Yes, the composed function has all real numbers, but the original function that got you there didn't. So you have to take that into account. Yes.
How do you put this stuff into the calculator?
Like to graph this one?
Yeah.
If you really wanted to graph this problem,
They have like a approach function.
you would have to type it in like this. Because if you typed in the final answer, the calculator would have no idea you had a square root. So if you type in parentheses, the square root of x, and square it, the calculator knows that you had a square root there that canceled out. And then do a minus 1. If you hit graph, see how it's a line, but it doesn't go past 0? Because the calculator knows the domain is only 0 and to the right.
Alright, can you use that to help you find the domain, or would you...
I use that to help me find the range.
Okay.
The domain you should be able to do without a calculator, but the range, that can be a little harder. So now by looking at the graph, I would say the range on this problem is every number from 1 to infinity, a -1 to infinity.
Okay.
So we're going to use the calculator to help find the range.
Alright, we need the. Alright.
But we don't need it for this one.
Would that be bracket? Yeah.
So, yeah, there'd be a bracket on that, right? So, again, this is what you're thinking about when you want to find the range. The calculator is going to help us. But the idea is, first, find the domain. And the range are the answers that you get when you plug in the domain. So the domain is what you plug in. The answers you get when you plug those things in are your range. That's what we're finding. So if you had something like x squared plus 3, and I said, what's the range? I'm saying, if you plug in all the different x values that you can, what are you going to get for y values? That's the range. And that's where visually it helps to see it.
So this is just like range like normal then?
Yeah.
There's no special rules for range of composition?
No, the domain is really the trickier piece, but as long as you get the domain correct, then the range will be okay. So what the domain tells you is basically, if you're looking at your screen, what's your x min and x max, right? That's what we want to use. So when we know the domain, like in this last problem, it was 0 to infinity. What I really should be setting my screen for is this. That should be my x min. And for my x max, I could just use like 20 or 30. I'm just going to pick a big number because I can't put it in. But the domain is very important to help you find the right window to look at to get the range. All right, so let's. I'm not going to do it both ways. Let's just do it one way. Let's do f of. We did. Let's do the one we didn't do. Let's do f of g of x. Let's do that. Yeah, I just want to do one of them. F of g of x. So f of, what's g of x? X minus 3. So what is f of x minus 3? Yep. Square root of x minus 3. Good. Square root of x minus 3. Okay, so domain. Look at the original inside function, g of x. Are there any restrictions on the domain of g of x?
The domain of g of x?
That's the inside function. Oh, Max?
What?
Are there any restrictions on the domain?
I don't know.
Ben?
No, but for the composition there is.
Right. For the original inside function, the answer is no, because g of x is just x minus 3. You can subtract 3 from anything you want. So the inside function doesn't help you at all to find the domain this time. The composition, though, does. The composition has a square root in it. So what values would you be allowed to use in the square root of x minus 3? Nate?
0. Oh, sorry. I'm sorry.
Couldn't go as low as 0.
Yeah. It'd just be 3.
Including or not including?
Including, yes.
So 3 to infinity. Now, that tells me where I should set my window. Let's graph it. So go to y equals, put in the square root of x minus 3, and let's set our window from 3 to infinity. So again, just set it, I don't know, go up to like 20. Maybe you can go, like 20 or 30, I guess. That's enough to, I think, see what's happening. So what does it look like your domain, or what does it look like your range is? Think about it. If you pick any number you want between 3 and infinity and plug it in for x, what would be the smallest value you would ever get when you plug in those x values? Yep.
Any real number above 0. Down to 0. Perfect.
Including 0. If you plug 3 in for x, which is allowed, you would end up with the square root of 0, which is 0. That is the lowest value you can ever get. The higher of an x value you pick, the higher of a y value you will get. That's how this one works. So it's from 0, and it will continue going up slowly.
Wait, what did you plug in for y?
What's that?
Or f of x, what did you plug in?
So we plugged in x minus 3. Right.
Oh, okay. Alright.
So range 0 to infinity. Question on? Okay. All right, let's look at this. So we talked about transformations yesterday, and I think this is getting towards the last thing that we're gonna tie in. So we're gonna end up writing some equations that look like a transformation, and it's gonna come from a composition. Okay, you'll see what I mean. So what we're gonna kind of do here is what we did before, but figuring out a different piece of the problem. So I'm telling you the answer to the composition, ax squared. What would a do in this case if you multiply by a number in front of x squared? What kind of transformation?
Isn't it the stretch or shrink?
Vertical stretch or shrink, yeah. So what I want you to do is figure out what g of x would have to be. So if I plug this into it, I get that. So it's like you're figuring out one of the functions you would need to create this composition. Does anyone think they see? And again, if you're kind of having trouble, think of it like this. You're plugging x squared into something. What could you plug x squared into so that you get ax squared? Yeah?
Would g of x could be a times x squared?
G of x would equal
A times x.
a times x. Because now, if you took x squared and filled it in right there, which is exactly what they said to do, you would get g of x squared, which would be ax squared. So basically, this problem is a vertical stretch represented as a composition of g and f. But it ends up coming out to being a vertical stretch. It's a little tricky to do, to figure that out sometimes. Let's try this one. So g of, remember f of x is still x squared. So what could I plug x squared into this time so that it comes out to x squared plus k? Yeah?
X plus k.
Yeah, x plus k. Because now, if you replaced x with x squared, you would change the variable to x squared, and you'd have a plus k. So this is a composition of two functions that represents a, what does adding a number at the end do?
Oh,
Shift up and down. This represents a vertical shift as a composition of two functions. Okay, not worried about that. Okay, so what we're going to do now is summarize basically those transformations we did yesterday, but when we learned them specifically for a parabola, that's great, but everything we learned yesterday actually applies to any type of function. Like, I gave you guys one like this, and most people knew that it was a shift up 3. Even though it's not a parabola problem, it still follows the pattern of adding a number on the end, which is always a vertical shift. It doesn't matter what you put there. Always vertical shift if you do plus a number at the end. So let's take a look and summarize these. Let's do it this way. So on the left, I'm going to put the name. And on the right, I'm going to show you the formula for it. If you multiply by a number in front of a function, not just a quadratic, but any function, what does multiplying by a number in front do? Yeah?
Vertically stretching shrink.
Yep. It's a vertical stretch or a shrink. Depends on the value of a. How about if you take any function and you add or subtract a number on the end? Yep.
Shifts it up or down.
It will shift it up or down. We're not getting into the specifics of which way is up and down right now. We kind of did that yesterday. How about if you add inside parentheses? What is adding inside going to do? Yeah. It's going to shift it left. If you subtract inside, it's going to shift it to the right. This one you get a little tricky. But if you put a negative in front of the function, what does the negative cause to happen? If you put it in front versus inside, one of them is one of them is the other. Then?
That's the reflection over x.
Yes. Think of this number as where the vertical stretch would be. This is a vertical reflection. When you reflect vertically, that's over the x. When you put the negative on the inside, it reflects over the y.
Can you scroll back?
So the last one we're going to look at is just making a sketch, and we're going to use these rules to do it. I'm not actually going to give you a formula. You're going to make a sketch without a formula. So this isn't a problem you could just type in on the calculator, because there won't be a formula for this picture we're going to draw. It's going to be a simple picture, but there's just no formula. So we're going to have to know these rules to do it. And I'll scroll back up to them if we need them. There's your sketch. That's what I want to use as my picture. And I'm going to transform that somehow. So it has a coordinate at -2, 0, 0, 2, and 4, 0. And that's the shape of it. Just like that. Now, I'm going to do some transformations on that. Let's say that this is f of x. I want you to find this. And you don't have a formula for f of x for drawing that shape, but you don't need one. All you have to know is what each of these operations is going to do to it. And we do have to follow the order of operations we mentioned yesterday when you do a transformation. So, in the thing that I have circled, what's the first number that you would focus on? And then we'll worry about what that number does. The 2, the +1, or the -3?
Plus.
We're going to focus on the +1. What does adding a number inside the parentheses do? John?
It shifts it 1 unit left.
It's going to shift it 1 unit left. Okay, so let's start with that. To shift this 1 unit left, we're literally going to take every point and just move it left 1. 1, 2, 3. So there's your sketch. Shifted left 1. What I'll do is I'll put this in red so you know what we just did. So that was the red. How about the next number? Would we focus on the 2 or the -3? Yep.
The 2.
The 2. And what is the 2 going to do? That's multiplying your function by a number in front. Caleb?
It's going to vertically stretch it by a factor of 2.
Right. When you stretch something vertically, what part of the coordinate does that affect? The x or the y?
Yeah. Why?
Y. Okay, so when you stretch vertically by a factor of 2, what that means is double all your y values. Leave your x's the same. Alright, so if we double the y value on this point, where would it end up? Same spot. How about if we double the y value on this one? It goes up to 4. And if we double the y value on the one in the lower right, it stays right where it is. So that is a vertical stretch by a factor of 2. You stretch it vertically. And how about the -3? What's that going to do? Yeah,
Down 3.
down 3. So take every point. 1, 2, 3. 1, 2, 3. 1, 2, 3. And the one in blue is the final answer. So we just did a transformation to an image without even knowing what the formula was. We didn't need the formula. We just look at the image.
Alright, so if we get something like that, will we get the original shape of that?
Yeah, I would give you original shape, and then for something like that, it would be multiple choice. I would say which of the following represents
Okay.
the answer when you do the above
Is there
transformations.
gonna be one like
Yep, I think there's one like that. I think the one in the homework, it's even simpler. It's like, I think it's a shape like that. And they have you move it up, down, or stretch it, and things like that. But I think it looks something like that. Other questions on that? Yes?
You said, so the horizontal shift went first, but that's not a horizontal stretch.
No. Horizontal stretch, we haven't really talked about it.
Yeah.
But the horizontal stretch would be like if you had a number like that.
Oh, okay.
It's not really something we've looked at yet. I kind of want to just get all these transformations pretty solid first, and then we'll throw that last one in.
Okay, thank you.
Yeah, we'll probably look at that next time we do transformations. Okay. Other questions on that? Okay. So that's homework for tonight on page 66. Okay, reminder, I will be after school tomorrow in case anyone needs extra help. First test is on Friday. And I think that's it.